Welcome to Working Effectively with Android Legacy Code. My name is Chuck, and I'm a mobile engineer at Button.
My name is Mohit Sarveiya. I'm an Android engineer at Vimeo.
And we're here to share some sad news with you all today, and that is Android isn't new anymore. Most of us are not working on greenfield projects. A lot of us find ourselves in the position of working on code bases that we didn't originally author, that are maybe hard to understand and difficult for us as engineers to maintain. And so we have all these exciting new tools and frameworks and things in Android like the Kotlin language, architecture components, testing frameworks. But when you're working on an older code base, sometimes it doesn't take advantage of these things, and you sort of get yourself into the situation which is like, where do I start? That's what our talk is about. So some of the things we're going to cover today are the definition of legacy code, the idea of finding seams in a code base, some techniques you can use to start to break apart dependencies, and then also strategies for evolving your code base and improving it over time. But before we get into all that, I want to talk a little bit about this idea of legacy, because legacy itself isn't necessarily a bad word, right? For example, what about the legacy of old school video games? How many people here had a Game Genie? Yes? No? A few? Okay. Yes. So here's an example of the legacy of home console gaming, and there, it's actually a really cool thing, and a lot of people collect old video games now and play them on their old consoles. Or what about old photographs? So these are some pictures that my drum teacher shared with me last time I was visiting him in West Africa. And when you get old photographs, they start to get that yellowish tint, and the ends of them start to curl a little bit, And this is also the example of a type of a legacy of, the history of that moment in time. Or what about Magic the Gathering? Here's a game where legacy is so important. There's actually a format of the game called legacy, and that's a good thing, right? Or for those of you who are really hardcore, there's actually a format called old school where you can only play cards that were printed in 1993 and 1994. So these are all examples of legacy in a good way. Well, what about old devices? So for those of you who don't recognize this phone, this is the original Motorola Droid that was released in November of 2009. This was my first Android device, and I shortly started developing for the platform after I got it. I mean, just look at this thing. It's got the sweet slide-out keyboard with the touchpad and the physical buttons. I actually quite enjoy this type of device and, look back fondly on the early days of Android. At the time this was released, it was running the latest and greatest version of the Android platform, Android 2.0 Eclair. That's API level 5 for those of you keeping score at home. And when this phone first came out, it was revolutionary, right? For a lot of us, this was where we started programming for Android. Well, so now that we've talked about the good feelings associated with a lot of different kinds of legacy, what about this? Wow, that's really hard to see. Well, the good thing is you don't actually want to read this code because this is something I wrote. This is something I wrote in 2009, shortly after getting my Motorola Droid. And this was basically a demo app that showed you how to interface with the contacts API, because there were breaking changes introduced in the contacts contract between Donut and Eclair. And so we abstracted that away and made it so that we could interface with on both versions of the OS. And so some examples of things in here are like a list activity, static Boolean flags, nested conditionals, async tasks, right from your onCreate method of your activity. We've all been there. And when you're working with a tangled mess of old spaghetti code like this, it can be difficult to know where to start.
So let's look at the challenges of legacy code and what prevents us from writing tests for it. So as Chuck said, this is a problem that many of you may face. You may have an app that was built many years ago. It's a large code base. It's very difficult to understand. So all these different problems, they all have a common theme. And legacy code is code which is untestable, right? And in this presentation, we're going to look at different techniques to get it under test. All the micro changes that you could make. So here's an example of a type of an activity, a login activity, and what it does is that it utilizes different classes. It shows an onboarding screen if you haven't viewed it. So there are a couple of issues in this code. One thing is that I'm utilizing singletons. Let's say singleton inside of it, it's using shared preferences to determine whether you have viewed the onboarding screen or not previously. So how do we get code under test, which is utilizing singletons? Another problem is that in my activity, I have these different dependencies I'm depending on event cache or login manager to do login. How do we break those dependencies apart? So the other problem is that I have a nested logic, business logic in my activity, and I want to break it apart so that I could test it. And another issue that you'll encounter is that, so when you look at different forms of legacy code, they all have, they're all structured based on some really bad design decisions. You may have legacy code where people started to use RxJava, but they misused it, and now they're at a point where they don't understand what's going on. So this is an example you could have an example legacy code which is based on inheritance. So here's an example of an activity which is part of a 10-layer hierarchy. Imagine every fragment in your app was part of a big, large inheritance hierarchy. In each layer of that inheritance, you have nested logic. So how will you get it under test? How will you work with it and add features to that type of a structured code base? So as an Android engineer, you have to find a balance. So your job is not to write the cleanest code possible, right? You also have to move KPIs, which are like key performance indicators. So the person who writes your paycheck or your product manager, they care about moving KPIs like by adding features to them, like increasing user engagement, right? So when you're working with legacy code base, you're not gonna get the time to start over again to completely scrap it. You're gonna need to work with it, you're gonna need to marinate it and make it better. So this talk was influenced by this book by Michael Feathers, really classic book I recommend everyone to read, Working Effectively with Legacy Code. And it has different techniques to get your code under test. So this presentation is not about it's not about specific architecture, it's not about writing the cleanest code possible. It's about, again, making the smallest changes possible, and they won't be, at first, the best changes, but they will be enough that it will buy you time in the future to improve your design. So now let's look at the reasons why you would change your app.
When we really think about it, there's only 4 reasons to actually modify a program. And for me, looking at number 1 and number 2, adding a feature or fixing a bug, these are kind of the same in my mind. And that's because either way, the end result is going to be some change in the behavior of the program. And let's be honest, one person's feature is the next person's bug. How many people have had a product manager come to them and say, oh, there was a bug reported in our latest build. Oh yeah, what's the bug? This feature isn't finished yet. So ultimately, these are both about changing the behavior of the program. Now, number 3 and number 4 are about keeping the same behavior, but improving the quality of the software. Number 4 is a specific type of change that preserves behavior, but optimizes resource usage. Maybe we want to consume less battery or less data over the network, or make the footprint of our APK smaller. But the type of change we're really going to zero in now on this presentation is improving the design, number 3 of your program. Another word for this is refactoring. And so this definition comes from Martin Fowler's 1999 book of the same title. And refactoring is basically changing the design of your code, improving the design of your code without changing its behavior. And this quote really gets at the reason why we would want to do that. It's in our own best interest as engineers to make the code that we work on easier to work with. And so 2 of the goals when refactoring, especially working with an older code base that might not have good test coverage, are sensing and separation. And the idea here is we want to start to take apart the dependencies that exist in our app or our library, and then be able to test them in a way that we can understand how they're behaving. This brings us to the idea of a seam, and a seam is essentially a place where you can change the behavior of your program without actually editing it in that same place. There are different types of seams talked about in the book: pre-processing seams, linking seams, and object seams. On Android, an example of a pre-processing seam might be like using your manifest to load different classes, or manifest merging rules. Manifest merging rules. Say that 3 times fast. Using Gradle to modify your build config, maybe set some different constants, even something like debug true or false. And then finally, loading different resources. These are all examples of pre-processing seams. Linking seams would be adding different compiled versions of your classes to the class path. Maybe in your test environment, you load some different implementation. All of these types of changes require a good amount of scaffolding to set up in a program. And so one of the easiest ways to take advantage of seams in already existing code is to look for object seams. And this is the idea of being able to inject a different implementation of an object at runtime. So let's do a quick exercise here. Hopefully you all will be able to see these well enough. So here we have an activity, and by the way, all of our code samples in this talk are going to be in Java because we want you to have the real legacy code experience today. So looking at this main activity, there's a bunch of code in here that I took out, but essentially the part we care about is in the onCreate method, we're going to show a status bar notification with some title and body text, right? Pretty straightforward. So what if we wanted to use an alternate version of the notification factory to change its behavior? Maybe we wanted to substitute a mock in our test environment to make sure that the notification is displayed with the text that we expect. Is there any way for us to do that without changing the code? No, right? We don't have a seam here. Don't all jump at once. There's no seam here for us to substitute a new version of notification factory without actually modifying this code in place. And if it's not well tested, that can be risky. Yeah, so that's what we're talking about. So let's look at another example here where, okay, now we see that a presenter has been introduced, and now our activity is delegating to the presenter to display the notification. Now, this is a good idea in theory. The architecture pattern of model view presenter has become very popular in Android over the last couple of years, along with others. But the idea of separating your logic from your activity is, in general, a good idea. Well, let's look at what the presenter's doing. It's basically doing the same thing our activity was before, in that it creates a new instance of the notification factory, and it calls factory.notify. So now do we have a seam? No. Exactly. So we have the same problem we did before, which really centers around the use of the keyword new. And so there's really no way for us to substitute a different version of that without modifying the code in line. I would argue that this example is even worse than the first one because we've hidden away our dependency on the notification factory, and we've polluted our presenter with an Android context, which, if we want to keep a clean separation of our presentation logic from the Android framework, now we're starting to mix the two. So let's look at one more example now. And this time, when we create our presenter in the activity, we also then instantiate an instance of the notification factory, and then we pass it in as a parameter to the constructor of the presenter. So now we actually have a seam available, because in our test environment, if we want to spin up a version of the main presenter, we can supply it with a mock or a test implementation of the notification factory. So this really gets at the idea of what we're going to be talking about today. And so, thinking about dependency breaking techniques, these are micro refactors that we can do to make the smallest, least invasive change possible and minimize the risk of getting our existing code into a test harness. Now, a lot of these changes, these techniques might look like bad design at first, but the idea is sometimes your code needs to get worse before it gets better. Sometimes we need to make these small trade-offs in order to get tests in place that will pave the way to more holistic improvements in the code base.
First technique is called Parameterized Constructor, and it's the simplest technique for breaking apart dependencies and injecting them. So suppose you have a disk presenter which is responsible for displaying the user details, like in the user profile page. So the problem is that I'm utilizing a singleton to fetch the user details. So how do I break my dependency on that? And I also want to break my dependency in a way that doesn't affect other places. So I have these other activities which are utilizing this presenter, and I'm utilizing this constructor, but I don't want to change it. I don't want my changes to affect all these different activities. So how do I do that? So the first step that I'm going to take is that I'm going to create a secondary constructor, and I'm going to inject my database manager in there. So now I need to tackle the primary constructor, which all the other activities are using. What I'm going to do is that I'm going to use the this keyword, and I'm going to call my secondary constructor, and I'm going to pass in that database manager instance. So this keeps all these changes this keeps all these activities invariant, so it won't affect them. And in the end, what this does is that it allows me to, helps me in testing. So the next technique we'll talk about, how do you create a test instance for a singleton. So when you look at this technique, there are 3 steps to it. First, I want to create my secondary constructor, and I'll supply as a parameters the dependencies that I need, and then I'm going to update my primary constructor to call my secondary constructor. Now, when you look at this technique, you might say that, why didn't I use a DI framework? So the problem with using a DI framework at this point in your journey to dealing with the spaghetti code is that it'll make things harder. So what this helps you with is that helps you with identifying all of the dependency that will be in your object graph. So, and then further on, you could utilize whichever dependency framework you want. To do DI, you don't need a dependency framework. So in the beginning, so it helps you with cut down verbose code. But okay, so the next technique we'll talk about is how do you handle this singleton and for testing purposes.
Singletons are particularly problematic when working with legacy code bases in that it's hard to get a mock version of your singleton in the test environment. Let's take a look at another example here of a presenter that relies, again, on the database manager singleton. And so here inline, inside of our onProfile button click method, we are grabbing a hold of that database manager singleton, and we're calling fetch user on it. Looking at the database manager implementation itself, we see all the hallmarks of a singleton in Java, where we have a static final instance that gets created when the class is loaded. We have a getInstance method that returns that reference. We have a private constructor to ensure that we don't have any subclasses, or that we can't create any subclasses of this. And then we have our public method fetch user. Well, this is particularly problematic if we want to use a test version of the database manager in our test environment. So what can we do? Well, we can make some micro refactors here and make a few trade-offs that might look a little bit gross at first, but will help us get our database manager under test. And then maybe once we have some tests in place around it, then we can improve the design, and maybe it doesn't even have to be a singleton anymore. But the first steps we're going to take to get there are, number one, we're going to take away the final keyword from the instance variable that will allow us to set a new instance of the database manager. Secondly, we're going to relax the scope on the constructor from private to protected, and this will allow us to create a subclass in the test environment, or a mock. Then we're going to add this new method that we annotate visible for testing that should only be called from your tests, and that allows us to override the default instance with whatever instance we give it. And so these are some minor trade-offs that will help us get the code into a more testable state. I think that's a duplicate of the last slide, so we're going to pretend that wasn't there. So looking at the summary for static setter, we first want to decrease protection of our constructor from private to protected. That allows us to subclass and override. Then we want to make the static instance mutable, and finally we add our visible only for testing method to set that instance.
Next technique is about how do you handle code which is utilizing a lot of static methods without using PowerMock. So here's an example I have of a video details presenter, and it utilizes a video utils class, and I'm utilizing many static methods in there to figure out what to display in the video details page. So when you look at inside of this utility class, it has a lot of static methods, and what I want to be able to do in my tests is create like a mock video utils class and inject it in. So the way I'm going to do that is that I'm going to create a public constructor for this video utils class. That's the first step. The second step is that I'm going to create instance delegators. So I'm going to create public methods and which delegate to the static methods, right, for each of them, for each of my static methods that I'm using. And then I'm going to go back to my code. And what I'm able to do when I do that is that then I could create a seam right at the parameter. And I'm able to inject in my test a mock instance of a video utils class. So does this mean that you shouldn't use static methods? No. This is another technique to not use PowerMock. So this is doing the smallest thing to get your code under test. And so there are 3 steps for there. First, you want to identify which static methods you're using, make the constructor public, and then create instance delegators for each of your static methods that you're using. So that's how you handle, guess how you get code under test that's using static methods. The next technique is a technique that I use a lot called extract interface. And this is really good techniques for working with God objects that know too much. You don't want to pass in like God objects around in your code as you're working with it. So suppose I work at Vimeo, so I was working on our video settings page and refactoring that. This is a technique that I use. So suppose you were utilizing a singleton and you were grabbing from the singleton the user object, and you were also using it to grab the user ID. But this presenter only needs that much amount of information. So when you look at the class itself, it's doing a lot of things, right? It has a responsibility for logging in, for tracking analytics, also for getting the current user. What I don't want to do is pass this God object around. How do I break it apart? How do I pass to my presenter only what it needs? So first thing that I'm going to do, I'm going to create an interface, right? And I'm going to have my singleton authentication helper conform to that interface, and I only have methods in there that my presenter needs, like getting the current user and the current user ID. So, and then I'm going to make my singleton conform to that interface, and then what I'm going to do is pass into my presenter in the constructor the user provider, and I'm going to mock that in my test, the user provider, to return like a fake user object. So that technique goes really far, and I use that technique a lot. So it's really useful for getting your code under test and dealing with God objects. So there are 4 mouthful steps, and you don't have to memorize this because the slides would be recorded. So it's basically identify what do you need from that object, right? Create an interface for it, and have that object conform to that interface and inject it into your presenter or your review model or whatever architecture you want to use. Or it could be a simple class. So the next technique is very similar to extract interface. It's called extract implementer.
So the last technique, dependency breaking technique we're going to talk about, is basically the inverse of extract interface. And so when we're using the extract implementer dependency breaking technique, let's look at an example of a notification factory, which we saw in some of the previous examples. And the public method here that we care about is notify, where we pass in a title, a body, and then a pending intent to be executed when the user taps on that notification. Well, let's say we use notification factory in a lot of different places in our code base, and we don't necessarily want to rename it. So as sort of the inverse of extract interface, we can actually extract out an implementation class. To do so, we keep the same signature and the same class name that we had for notification factory, but we turn it into an interface. And then we rename our concrete class that backs it something else. So in this example, a simple notification factory. And what this allows us to do is then seamlessly pull out an interface from an existing class without actually having to modify any of the places that class is used. This technique is so easy, I didn't even bother writing out the steps for you, but I still wanted to bring it up here because you're going to see it again later when we get into some of the strategies for adding new features to your software. So dependency breaking techniques, again, these are micro refactors that you can make with a minimum of risk to help start getting a legacy code base under test. We spoke about these 5 techniques today: parameterized constructor, extract interface, instance delegator, static setter, and extract implementer. There are many others in the book, things like parameterized method, subclass and override, and a lot more. So I recommend you check it out when you get a chance. But now we're going to shift gears a little bit and talk about, now that we've started to sort of take apart dependencies and kind of give ourselves a seam that we can start to introduce tests to our legacy code base, now how can we get back to moving those KPIs like Mo talked about, adding new features, fixing bugs, improving the actual behavior of the code base. So the first strategy we're going to talk about here is sprout method. Let's say we have an event tracker class in our code base, and the responsibilities of the event tracker are twofold. This is our way of collecting metrics. And so when we have an event that we want to monitor about our users' behavior and how they interact with the app, we do 2 things. We send off an HTTP request to our server to report those events, and then we also write them to shared preferences, so we maintain a local cache. And so we can see that most of that is happening through this track events method, where we loop over the list of events that's passed in. And we then also write that event list to shared preferences. And here's an example of what that looks like in a simplified version. That's actually the graphic for an iPhone, don't tell anyone. Okay, so looking again at our track events method, let's say our product manager comes to us and says, we have a new requirement. Wouldn't it be cool if we could, before reporting the events to the server, deduplicate and make sure that we're not reporting any events we've seen already? So if a user sits there jamming a button over and over and over again, we only report that click once. Okay, great. How are we going to do that? Well, remember, this is a legacy code base, and we might not have good tests in place around the current behavior of the event tracker. And so one option for how to implement that deduplication would be to just get in there and add that check right in the middle of our loop that's reporting the events to the server. So now when the list comes in and we loop over each event, we want to check and see if we've already cached that event locally to the shared preferences. And only if it isn't already stored in our local cache do we actually report that event to the server. And then afterwards, we write that list to the shared prefs of all the new ones that we reported. Well, this will probably get the job done, but this is also an extremely invasive change that takes on a lot of risk in an older code base that isn't well tested. So maybe there's a different way we can approach implementing that same new feature. Yeah, so that's where we were actually looping over it and making the invasive change. Well, as an alternative, what if we introduced or sprouted a new method called unique events? And the purpose of this method is to simply look at the list coming in, compare it to the local cache, and then return the subset of events that are net new. We're also going to give this method package private scope so that we can test its behavior from our test environment. Now, when we go back to the event tracker, we introduce our new method, and all we have to do is simply call that new method from track events. And so this makes the change much less invasive because we're only modifying one line of existing code rather than messing with the logic contained inside the loop. And you can imagine in a more complex code base how this can be particularly helpful. So when you want to use the strategy to sprout method, first you want to identify where we're going to make the change, write a new method that does that work. Any local variables that that method needs, you pass them in as arguments, and then you can write a test for your sprouted method, and then finally invoke the new behavior from the existing code base. But sometimes sprout method isn't enough.
So you could also utilize the same technique, similar technique at the class level. So here's an example of applying this technique. Suppose you're working on an app and you have authentication feature, and you could log in different ways, Facebook, Google, or with email. And you have a class which does that for you. And imagine this class has all the logic is in there, thousands of lines of code, and you want to go in there and add a new feature in, which is for forgot password feature inside of it. Now, how do I do that in a testable way, right? So in order to do that, I'm going to sprout a class. Rather than adding my logic into that activity, I'm going to sprout a class, call it login presenter or login view model, and then I'm going to inject in my API client that I will need to make a request to reset your password. So after I inject that dependency, I'm going to add in a simple method in there to when they click on forgot password, or when they reset their password, I make the API call. So, and then when I go back into my login activity, I'm going to update it to use that presenter. The key thing to note here is that when I go about doing this, I'm not refactoring that whole activity. I'm not refactoring that whole activity to utilize this presenter only for the new change that I want. I could refactor it into MVP in this example as I work on adding more features into that activity. So you could take an iterative approach to it. This is a technique that I utilize a lot every day. So there are 3 methods in there. First, you want to identify what are dependencies that you will need for your new feature, and to create either a view model or a presenter or any regular class and inject your dependencies in there and have your logic inside of it. So with this technique, you could utilize all those other techniques like Parameterised Constructor and extract interface to get your code under test. So in reality, you would utilize all these different techniques together in combination. So the next technique is a really delicious technique. It's about how do you create burritos using wrap class.
Yeah, so the last strategy for modifying software or evolving your code base that we're going to talk about is wrap class, or otherwise known as the tasty burrito strategy. So going back to our notification factory example we looked at before, we have the one public method of notify, which displays the status bar notification. So once again, our product manager comes back to us and says, hey, wouldn't it be cool if we tied in our notification factory to our metrics, our event tracking framework, and when the user saw certain notifications, we were able to report that event to our server and maybe the click of it as well. Well, okay, but the catch is we don't want to do this for every notification we show, only key ones that are drive our KPIs. Okay, well, so we have a few options of how to add that new behavior into the notification factory. We could stick a Boolean parameter on the end of the notify method that's like should track, and then you could do an if statement that's like if should track, then call event tracker, create it inline, right? That would be the quick and dirty way of hacking it together. We could also sprout a new method or sprout a new class, which are techniques that we've already talked about. But we're going to look at a slightly different approach of how we can solve that same problem, minimizing the amount of changes we have to make to the existing notification factory. So again, we're going to go back to our extract implementer dependency breaking technique, and we're going to create an interface for the notification factory that exposes that public method notify. We're then going to rename our concrete class from notification factory to simple notification factory and have it implement the new interface. Now, this is going to allow us to introduce a new class called tracking notification factory. And the key here is that this is going to use the decorator pattern rather than inheritance. So this is not a subclass of simple notification factory, but rather it's another implementation of the interface. Then what we do is we pass the original simple notification factory into the constructor as a parameter, and we store it as a field. We also pass in the event tracker, which happens to be the other dependency we need in this situation. Now, when we utilize the tracking notification factory from part of our code where we actually want to track metrics based on these notifications, we can call the new line of code to track the event, which will then send that report off to the server. But then for the rest of displaying the notification, we just delegate to the pre-existing notification factory and not change its implementation at all, thereby minimizing the risk of introducing the new class and the new behavior. So when you want to use the wrap class strategy, first you identify the existing class or method that needs to change. We're going to create a new class that accepts the original class as an argument to its constructor. Then we're going to delegate any method calls to the original class and put in our new implementation only that new behavior that we want to add to the program. So strategies for changing software that we talked about: Sprout method, Sprout class, wrap class. These are all ways that you can start to evolve and introduce new features into a legacy code base, minimizing the risk on the existing code that's already in there as you start to get it into more of a test environment. Other strategies talked about in the book: wrap method. It also talks about things like TDD and pair programming and many more different strategies of how we can start to get an older system under test.
So what are the things that you could take away from this presentation? So when you apply these techniques over time, what will happen is that you'll start to see more code coverage in your code base, and you can start to then think about architecture, and you can start to think about I think this is good. You can start to think about like MVP or architecture components, and what you could do is that as you start to apply more of these techniques is take one feature and make it a style guide for your architecture that you're going to use, your view architecture, like architecture components, MVP, MVVM, or MVI. So, and the other part is when you're dealing with the spaghetti code base, when you look at it, there are a lot of things that you could rewrite, right? And your job is to, when you're interacting with like product managers, is to figure out what are the KPIs that I want to target. What's the most important problem that I want to work on first? So in order to do that, you could take a data-centric approach, where you could look at your ANRs, your crashes, your bugs, and your performance, and your roadmap, and based on that, you could figure out what problems is important. So I'll give you an example of it. So at Vimeo, I work on the platform team where I work on architecture, and my 80% of my job is coming up with a good argument as to what problem I should solve. So recently I worked on changing from JSON to Mashi. So the approach that I took was that I came up with metrics like how do you quantify serialization performance, look at that, and I changed one feature in the app to utilize Mashi, and I integrated Firebase to look at the performance of it, and I integrated other tools to look at performance, serialization performance, and how it looks with network performance. And so my KPIs were, is it faster than JSON? So it gave me really good data that I could go to all the stakeholders and say, hey, I did this because this was the reasoning. It improved the performance of the app, right? So that's very important. It takes a lot of creativity to do that because not everything has like user-facing KPIs, right? So I hope you guys enjoyed this presentation. All the techniques were really simple, and many of you might be using them every day, but it gives the book, Working Effectively with Legacy Code, gives you a really good vocabulary so that you can speak with your fellow developers, hey, I'm utilizing this technique. So thank you all for coming to our talk. Thank you.
Thank you.
Is there ever a point where you consider a code base irredeemable and should be completely rewritten?
It's a great question, and I hope I have a good answer. So my friends who work at various different companies, they have taken that approach of rewriting their app from scratch, because it depends on like where the company that you're at, because it's not just your decision, right? So, I mean, you also have to get your stakeholders in, or whether they're okay with it. So, I mean, there are a lot of things that go into that, deciding that. Sometimes from a developer's perspective, when you look at the app, you might say to yourself, hey, I need to rewrite this. But then, are your stakeholders okay with that? So then you have to, that's when all the techniques we talked about come in handy, where you're going to have to work with that code base. Especially, imagine you have an app which has millions of users. Are you going to stop development in there? Because what are those users are going to say to you, right? They're going to be gone to another app. So that's my best answer.
So the question is there any way we can minimize the amount of regression testing that needs to be done when you're adding a new feature to a legacy code base? Well, I would say using these techniques that we talked about. So if you're able to localize the changes to just one portion of the code base, one portion of the app, then I would focus your efforts on testing just that portion. I've seen a lot of efforts to introduce tests to untested code kind of go wrong in that you're sort of just writing a bunch of tests for the sake of writing tests. But if that code is working and it's not changing on a regular basis, I would say just leave it alone. If you focus on adding tests where you're actually making changes to your app, you'll see that over time changes start to cluster together. And if you introduce tests for the parts of your app that change most often, that's arguably where you need them the most. So that would be my advice.
Wondering what is the next step for this refactor? So the end goal is like refactor the whole object or class, not just add a feature or fix a bug. So I would really like the iteration approach for this. I'm wondering the next step for this.
Okay, good question. So I would say the next step is to write the test. So one of the things that I really like about this talk is that we managed to do a whole 45-minute talk about testing without showing you a single test. So the next step is, after you do these techniques, actually write the test. After that, I would say just start to migrate your code slowly over time. You know, if you introduce a presenter for an activity, for example, only add the one method that you need, as Mo talked about in his example, and then maybe next time, next sprint, you want to change like the input validation on the username and the password field. Well, then you can bring that over into the presenter as well, and I would just do it piece by piece like that.
Hi, is there like a strategy for migrating from like Java to Kotlin?
I'm going to stay back here and let you handle this one.
That's a great question because I've been using Kotlin before Google officially announced it. So with my colleague Brent, who's sitting back there at Percolate. And so the strategy that we utilized at Vimeo is that we started to use Kotlin for unit testing first, right? It gives people a taste of what it is, shows them the light, right? And so utilizing, there are so many different things that we do. For shared preferences, like we use techniques for, like we created a delegator, and we create obviously many different extensions. We use a fragment delegator to pass things around from activities, to pass things around to fragments. So there are a lot of talks which talk about these design patterns that we use a lot at Vimeo. Yes. So that would be. There is a great talk by Israel on effective Kotlin that I think you should check out, which will talk about that.